Conditional probability. The probability of an event given that some other event has already occurred. So it looks like this. What's the probability that event B happens if A had already happened? Or the probability of B given A. And the formula looks like this. We're going to take the event A and B and look at the n values, so where they intersect, and that's going to be divided over event B. Now let's see, I found this. So if we have a ball and we know it hits the red shell first, so I'm dropping from my line here, and if it hits A first, there's a 50% chance that it hits the blue shell. Right? So if it drops and hit A, there's about a 50-50 chance that it also hits B. Now I can adjust this, make it A longer. Let's adjust a little bit more. Let's actually make B smaller. So the probability of hitting B after hitting A looks like it got minimized to 24.1% chance. Now if I make B larger than A, then would it not make sense that there's a 100% chance that after hitting A is going to hit B? Because there's no way that the ball will not hit A and also hit B, because B is so much larger. So that's what we're looking at with conditional. Now this also does a nice job at looking at the law of large numbers. So remember I said the law of averages is a lie? Doesn't usually work. As we see here, notice this is what's demonstrating the large of averages. But as this, I just keep this going to infinity, notice how it's going to get closer and closer to our estimated values. That's the law of large numbers. So law of averages is where it starts, like so. Notice how it just kept on jumping around. Law of large numbers is as I just keep this going. So let's look at some examples. You draw a card at random from a standard 52 card deck. Find each of the following conditional probabilities. So the card is a heart given that it's red. So what is the probability that I draw a card that is heart given that it's red? Now, first we need this unit set here. So what I want to do is look at red and how many of those are hearts. Well, here's my red cards. We have 52. So out of 52, let's divide by 4. That's 13 apiece. Now, how many of my red are going to be hearts? How many hearts do we have? 13. So that's 13 out of a 52 card deck, and we're going to divide it by B, which is how many are red? Well, half of my deck is red, so that's 26 divided by 52. And do this math, I see 13 over 26 is 0.5. Now you don't have to use this formula. I prefer that if you could figure out the logic behind it, then that's probably the best case, which is how many hearts are composed of red? Well, if I have 26 reds, right? How many of these are hearts? Well, 13 of those are hearts, which equals to 0.5. So I have a 50% chance that if I draw a red card, it's going to be a heart, which should logically make sense, right? So, what's the probability that the card is red, given that it is a heart? What do you think? Probability that the card is red, given that it's a heart. Perhaps I should have just kept this on all slides. What do you think the probability is? Probability that the card is red, given that it is a heart. Well, let's see. How many hearts do I have that are red? 13 over 52. And how many cards in a deck are hearts? 13. So that's 13 over 52, which is 13 over 13. So how come nobody saw that? It was pretty obvious that if you have a red card, or if you have a heart, that it's probably a red card.
So what question did we just answer?
The opposite. So I want to grab, what's the probability that if I take my card is red. What's the probability of that being a heart? It's 50-50, right? Either going to be heart or diamond. Now if I say my card is a heart, what's the probability of it being a red? Well, that's 100% chance because there's no black hearts. Now, the card is an ace given that it's red. So how many reds do I have? How many reds do I have? 26. 26. Of those reds, how many are aces? 2. 2. So that is a 1 in 13 chance of me telling you I have a red card. What's the chance of that being an ace? A 1 in 13 chance. Everybody with me so far? Okay. Again, we've kind of done this already. We've just given a name to it, conditional probability. The card is a queen, given that it is a face card. The card is a queen, given it is a face card. So how many face cards do I have?
12.
12. Very good. So out of 12 face cards, how many queens do I have? How many queens are in a deck? 4. So I have a 4 in 12, or a 1/3, or a 33.3% chance of one of my face cards being a queen. 33% chance. Again, if you were to use a formula, what you would do is, how many face cards? You have 12 out of 52. How many queens do you have out of the deck? You have 4 out of 52. Again, these fractions will cancel and give you 4 over 12. Let's do a table here. I have cats, dogs, and they're either male or female. Now, cats, let's see, dogs, I know I have 8 males. In cats, I have 6. I also have total. I know I have a total of 18 cats and a total of 24 dogs. Now, how many female cats do I have? 12. How many female dogs do I have? 16. Let's also do totals here. How many male totals do I have?
14.
How many?
14.
14? And how many female totals do I have?
20.
What's that?
28.
28. Which means I have how many total? What's that? 42? Thank you. So remember doing this months back, a conditional probability table. Now we would take the percentage of each of these. That's kind of what we're doing here, what we're doing in pieces. So what is the probability that a pet is male given that it is a cat? So I'm looking at males. Given that it's a cat, what's the probability that it is a male? So I'm dividing what by what? So cat, I have how many total cats? 18, right? What's the probability that it is a male? Well, out of 18, 6 are males. So my probability is 6 over 18, which is what? 1/3? 1/3 or 33%. Now let's look at the pet is a cat, given that it's a female. So all of my females, which I have a total of 28, out of my females, what's the probability of it being a cat? So how many cats do I have that are female? 12. So I have 12 over 28, which is roughly a 0.43. I have about a 43% chance that if I were given a female, then it would be a cat. Last one. The pet is female, given that it is a dog. So I have a total of 24 dogs. Out of those 24 dogs, 16 of them are female. So 16 over 24, I have 2/3 or 67% chance of, if I was given a dog, that dog would be female. What is the probability that somebody, so we want somebody who watches football and watches basketball. So we're looking at here and here, right? Given that she also likes to watch basketball. So how many people watch basketball? 38. So I'm adding these two numbers together, it gives me 38. So a total of 38 people watch basketball. How many of those people watch football? 24. So 24 over 38 gives me 24 over 38. 0.63. So about 60% chance of girls who watch basketball probably also watch football.